Okay. Okay. So till now, what we have covered is hyperparameters and model validation, feature engineering. Okay. Linear regression, logistic regression, things around naive Bayes, right? And we have more focused on the learning part of it. I mean the process pipeline part of it. Actually, let me pause recording for a minute. Okay. So now what we'll do is we'll try to learn our first what we'll try to do is we'll try to learn our first unsupervised algorithm. Okay, and see how it is doing it. First experience of unsupervised algorithm. Okay, so again I'll GitHub Zekelabs. Okay, so you have this guy. So here I'm actually trying to prepare book sort of thing. Okay, so you can revise all your NumPy pandas in one notebook here. Okay, then some diagrams I have. Like last time everybody was confused with the flow and all, right? So I prepared this diagram. Okay, so you can get here data gathering, data cleaning, data processing, visualization, machine learning, supervised, unsupervised. If it is supervised, regression, classification, unsupervised, clustering, association. Of course, there are a few more varieties here. Okay, like regression, there are a lot of varieties. I haven't written all those details. Very difficult to write it like this. But yeah, after this you have training. But training data needs to be featureized. That means converted into numbers and all that. And then it will get into training. Then you have model validation, right? Accuracy and all those things will come into picture. And after that, you will do the prediction part using it, right? I mean, you'll find out the best model, and the best model will be used for prediction, right? This is the entire flow of the process, right? Okay, so we have dealt something around in supervised regression, classification. All these things we have done for supervised, right? Now we'll do for clustering. Okay, okay. So let's see.
Everybody can access it.
Yeah. I wouldn't want everybody to keep accessing this, and if you want fork this page, or like I am preparing a material, I mean more organized. Whatever I have is little unorganized because a lot of classes happen and becomes unorganized over a period of time. This I most likely will publish it in form of a book. Okay, where it's some theoretical concept, whatever we have discussed, right? It is mentioned here with some diagram, some APIs. So we're continuing to add more information, but it takes a little time. Okay, like model validation, regression, R2 square, mean square. So it will be sort of a summary. Okay, cheat sheet with some projects, right? That sort of thing. That means, so like people like you who have finished the course, you need something to catch hold of, right? I mean, you know a lot of things, but some pointers. Okay, this is how you do. This is how you do. That sort of information, right? Okay. Now let's see. Okay, so okay, so what we'll understand is first our unsupervised machine learning. What is unsupervised machine learning? When do you use it? So first thing is, what is unsupervised machine learning?
Google also launched new one.
Oh, somebody removed mine.
Yours is this one was?
Yeah. Huh?
Mine is good. Yours good.
You are using some pirated mail version. I note down the meeting ID. Strange.
Is Google also learns me?
Right. It is. I actually have created an account. That is good. I like it. Okay, so it is collaboratory.
Like Jupyter, there will use one more.
Collab.
I
wanted to develop a platform. I think I was talking to you for TensorFlow executing. That's what they did it actually. And this, I already knew and I checked it. Oh, this works. Okay, see this. I was trying to import TensorFlow, my account, and in TensorFlow, we do everything. And the best part is, this is very useful in actually doing, club trainings. I can share this. I will use this in corporate trainings because there will be, a lot of people on ground, off ground. It is very difficult to share information. Like after the class, I'll just share the link. GitHub actually have to upload it. Two-step process. They are live. Like you are doing some changes, they want to copy paste something. Okay, so I just shared the live link with them. Atom, I have this. Cloud based, huh? Is that is free? This part? I doubt. So this is good. I like it. I always am a big fan of this notebook sort of an environment. So they did it. This was awaited. I thought if somebody doesn't do, then we can do it. It is sort of that thing. iPad notebook. Where is it? Notebook. This. They are internally using Jupyter Notebook server. The way I'm running it. So you saw me running it on AWS, right? Same way they are doing, right? Just when I connect, they will give a new port to me. That's it. So it is very easy to implement. That's why I thought if nobody does it, I'll do it quickly. Okay, let's come back. Okay, so what is introduction? So first is introduction. What is unsupervised machine learning? Here there is no target information, right? Second thing is you are trying to find relationship between the data.
It means that we don't require another code, right?
You can do it in cloud.
Means like just type it and you can find that on fly.
It takes 1 day to give you account now. Okay, because it has to it has to keep it live forever, right?
Oh, it's free only.
My screen is not refreshing.
That's what I didn't get mail also. There's some problem with your connectivity.
You can take the number.
No, mail. How can mail be problem? So let me share.
You are sending that.
Everybody has got mail except you, by the way. But yeah, in sent items it doesn't show your name.
See.
Just tell the meeting address.
No, but even when
No, it shows. I didn't refresh. It shows. As a meeting ID note down. 826. Browser. How is it possible your email ID is not getting It is Yahoo and you're checking Yahoo only. That's what you're checking in.
Yahoo closed, but mail is there.
Yeah.
Give another email ID. That would be better, right? Next time. You will add it.
Trying to what is it? Trying to find relationship between the data. That is the objective here, right? Okay. Then the third point is what you're doing. You're trying to find relationship. We're trying to find. Okay, it gives you. So whenever you get data first time, you really don't know what to do. Most likely, unsupervised machine learning is something that you do that. Okay, to get some sense of the data.
Not refreshing.
Avantik?
Yeah. So is what happened? It is not refreshing.
Yeah, it's not refreshing, and
What do you see? I see here everybody is fine.
yeah, but this data science, page GK Labs data science training, that page is, that is the one which I am able to see it.
Oh, so can you reconnect? Because everybody else is, I'm seeing it fine here.
Shall I reconnect?
Yeah. Do that.
Okay.
Okay. So no target information, trying to find relationship between data.
I'm able to see when they just allow me to recording.
Hmm. Yeah.
Thank you.
Sure. Okay. So trying to find. So what you're trying to do is trying to find relationship between the data. Okay. And it is generally done when also done when you don't have any idea about data. So I actually like data analysis. Okay, like yeah. Actually, first thing is in satellite data. Okay, satellite data gets a very raw format. You don't know what is what. You get some dump of petabytes of data. Actually, satellite data. You don't know how to see, how to understand that. What you do? You do first unsupervised algorithm. It will bring similar data together. Like for example, you know that this coordinate of the Earth is C for sure. You will see what are other coordinates which is coming to that. So you'll understand this is all C. Understood, right? Okay. Similarly, for example, customers. You have a large list of your customers, right? You want to identify what is a marketing strategy that would work for all of them, right? What is a marketing strategy that would work for all of them? So what would you do in that case is
But for that, some business rules will be there. Market strategies.
So you have to find the marketing strategy for, you have, suppose you are Vodafone, right? You have billions of customers. You have to break the customers into three groups. So one thing, you have to sell it in one group, which should be sellable. I mean, you should know different strategy. Something, they have premium customers that won't sell to me. Maybe that would sell to very rich folks, like premium customers with 10,000 fees, 10,000 premium every month or so, right? So when it has customer segmentation, this is used unsupervised. You want to divide your unknown groups of customers into some groups so that you can plan your marketing strategy. Understanding satellite data, image compression. How image compression? Because see, when we'll do this image compression example, okay, suppose you have an image with a lot of pixels, a lot of different type of colors here. Okay, to store a lot of colors, you need much more image size, right? Much more. So you want to compress an image to 3-color image, right? What will be the 3 colors? No. Huh? No. So actually, on the contrary, 3 color will be no standard answer actually. So they suppose the image already has a lot of colors. Okay, the three main color will be the 3 color which would represent all the 96,000 colors. Let's take an example. Okay, so it will be 3 cluster of colors. That means all the similar color will be converted to this color. All the similar color will be converted to this color. So these things are used in image. A lot of cameras, a lot of this image processing tools uses this. Okay, let's see with a small example, so that we start feeling it, have then we'll understand how to do the costing and all that. Okay, let's see a small example.
So this cost function we use in unsupervised. Cost function.
Yeah. Okay, so I'll explain this with one example. kMeans, right? I'll explain with some visualization example. Right. So you can see here 5 points right here. There are 100 points. Anybody colorblind here? Right. Okay. So you can see the colors here, right? Total five colors. So what these? Imagine these all as customers. You can see from the you're seeing. You can, these all are your customers. Okay. Imagine that each customer is represented by two features. One is this feature. One is this feature. Okay, that means there are two features by which you are representing a customer. That is why you can represent it in a 2D frame. The one is X, one is Y. Okay. Now what you have to do is you have to group the 100 customers into 5 groups. Right? These so for random groups, we want to first find the 5 random groups which you can do that. You can do that. Now the point to understand here is the initial points you will take. Now we'll understand the algorithm how this will happen. If initial random centroids, you remember what is a centroid? Center of a cluster is known as centroid. So these 5 points, you randomly choose the centroid first. Then you associate each point to the closest centroid, like this. Fine. So this is the first step. After this, what we'll do? This is one group, one cluster, right? Okay, this is one cluster, but the centroid is very much, centroid should be in the relatively center to all the points, isn't it? So the next step will be shuffling the centroids. The points remain the same. The centroid is recalculated because initially it was random.
So that color one it came to move. The color one which previously 5 points, right? That 5 points only it moved, right? It moved recently.
Right.
Why the shuffle?
See, that is what you have to do. You have to find the best centroids.
Means what are the parameters which define the best centroid?
It should be at. So I'm answering to her question, and that is apparently my next talk. Right. So this part first is from all the customers. Just imagine you have a lot of customers. You randomly choose. Okay, 5. You have to divide the entire data into 5 groups. So I randomly choose. This is one customer. This is one customer. This is randomly. After that, all the customers who are closest to this customer, right? All the customers were closest to the customer. That was the first stage. After that, you created a cluster, isn't it? Okay. Centroid should be a point. Okay, which is at if this is the centroid, sum of distances of all this should be least. That is cost of a cluster. Note down what is cost of a cluster. Cost of a cluster is distance, L1 distance. But you remember what is L1 distance, L2 distance? L1 distance is absolute value of distance between two coordinates. Right? This is this coordinate and this coordinate. You have to find L1 distance, just subtract between them and do absolute value. That is L1 distance. L2 distance is the distance between this guy and this guy, square of it, and then sum of all the distance and square root of it. Euclidean distance is also known as L2 distance. That is sum of square of differences of all the points.
Avanti, can you please repeat cost of cluster?
Cost of cluster is sum of the difference, sum of square of the sum of difference between coordinates of this guy and this guy for all the points, and then square root of it. That is cost of a cluster. That is RMSE. Root mean square. Okay, that is cost of a cluster. Your centroid should be a point from which the cost of a cluster is least. Fine, right? Okay, that means all the points are at a decent distance from here. Okay, cost of a cluster is least. So this is, so once the centroid has moved, remember this. Next step is there might be some points for which the closest centroid is like for example this point. This centroid is far or this centroid is far. Right? So now there will be some reassociation. Okay, there is some reassociation that is happening. Once the reassociation happens, then again something has changed in the cluster. So again, what will do? You will recalculate. Exactly. Again, what is the next thing that we will do? Right. Right. So till what time you will continue doing this?
When we get minimum cost.
Right. Till not minimum cost. You will continue doing this till there is no change in relationship between the point and the cluster. Okay. See, it is still happening, reshuffling, still happening, reshuffling, still happening, reshuffling, still happening.
There is no change in.
See, continue, see the image. Still reshuffling is happening. Now there is not happening, so it is completely stopped. So this is the best customer distribution.
Could we just continue to do this till there is no change in?
Till there is no change in data and the cluster relationship.
So this is kMeans algorithm, right?
Yeah, this is kMeans algorithm.
So what is K in this one? Is it the number of points that we calculate?
K is the number of centroids.
So how we determine what is the correct value for K?
Exactly, that is what we'll discuss. Now the next point is, okay, how do you find out what is the optimum number of clusters, right? And that is what you have to calculate. You have to find out the optimum number of clusters. Okay, so there is this elbow algorithm. Elbow. So I'll show you. Before that, we'll try to understand this cluster first, and okay, that is a very important case. Given the number data size, actually we'll do a very interesting case. Anybody knows how many alphabets are there in Arabic? Sure. No, sure. I don't know. Or you just guessed it? Okay, then I don't know. So we have a lot of handwriting characters of Arabic. So what we'll find out is how many characters are there, actual characters. A lot of handwriting is there. Like, it is like you did some manuscripts. Historical, archaeological digging and all that. You got sort of alphabets. You have to understand that. I think first thing that you'll do is unsupervised algorithm. Okay, it will bring all the similar looking stuff into one category. So it will give you, these all things might be meaning the same one alphabet. This is one alphabet. You can group them, right? After that, you will say, this language had 32 characters. Okay, and seeing the grouping of characters, you understand this is the most used character, this is the less used character, this might be vowel, this might be consonant, right? This is how actually you can do those analysis. We'll do that case. First, we'll do with MNIST. Okay, one cost, you understood what is the cost? There is a very important understanding. What is the cost of a cluster? Cost of a cluster is basically difference between this point and this point, square of it and sum of all them, and then square root of it. That is cost of a cluster.
28 alphabets.
Huh?
28. English.
Oh, is it? Oh, then we'll see the algorithm. Nice. No, we'll see this algorithm. Okay. So what will you do now? We'll use MNIST data. Okay. We can use larger data also. We have 55,000 data sets. I'll use a smaller data set, the 2 data sets. I think we used last time 55,000 data sets, right? Of MNIST data. Right. The image, the person's image processing that we did and all that. Okay, so I'll use a smaller data set this time. Just to do it quickly.
Digits,
This is your MNIST data actually. So we'll use unsupervised algorithm to identify, to group things together.
Maybe for grouping.
Clustering. Okay, so what is this data like? Data has 1797 data, and it is a smaller version of it, 8 cross 8. Okay, so if you want to see the data, what will you import? Matplotlib line. So now, okay, so plt dot im show, right? That is how you see images, right? Okay, data dot digits 0. No, it cannot come. Not shape 8 cross 8. Okay, a second. Digits data 0 dot shape 8 cross 0. Oh, sorry, reshape. Huh? I gave shape only. Yeah. Right. This is first data is 0, 8 cross 8. Right. Okay. So and grayscale. I mean, it is a one single value with color. Okay. There is no RGB and all. Only one dimension. Okay. This is a image. So you have such 1700 images. What you want to do? You want to group them all together. You have label information. I don't want to use the label. Imagine the first time we are seeing these characters. Forget that we know this is MS data and all that. Okay. Now you want to what is that you want to find out? You want to find out optimum number of characters. Of what is the best number of what is the total? This is handwriting data, right? Number handwriting data. Okay. Forget that we know that this is possibility is 10. What you have to find out is what is the best number of clusters to divide the data. Okay. So for that.
So it is actually supervised, you're taking only the target, I mean features, so that will be unsupervised.
Right. Okay, just a case. Okay, so let's this is your kMeans. Okay, then yeah. Okay, so we'll store the cost here. Okay, then for plus k in range, we want to test for till 1 to 20. Okay, that means we will try to train the model and all this for 1 to 20. kMeans. Okay, this is the model name. kMeans. Number of clusters. Number of clusters is equal to k, right? And then a random state means how, you know, whenever training the model, how randomized you do want you cannot. Then what is the next thing you'll do? You'll to train the model. Get digits or data. This is, see, there is no target information passed here because this is unsupervised. Okay. Then what you want to do? You want to calculate the cost, isn't it? You want to calculate the cost. So what it for? I want to print it also. Print k comma kMeans dot score this is cost of that particular cluster, I mean cluster every time, and I want to store it in my cost array also. Cost.fn. Okay, and okay, the cost will come in reverse order actually. Okay. Okay, let me first, actually -1 into the cost, right? Okay, it is using this L1 cost by default. Okay, L2 both are L1 cost by, so it will actually come in negative thing. So no. Yeah. So this is just for sake of plotting.
Cost won't be negative, right? Because it is square.
Yeah, exactly. But we want it to be in negative so that we get lesser to higher. I mean, essentially for sake of sorting, nothing much. Or actually, let's not confuse it now. Just store the cost first. No? Okay, so this is what it will append, right?
We are not splitting it.
Hmm?
We are not splitting it. Right.
Not required. There is no. Yeah, there is, I mean, we want to. There is no label information.
But how will we see the accuracy then?
Cost. That is what the accuracy is different. I mean, here it will be the cost. You really have to find relationship between the data. Okay, so I'll show you what other ways you can do the similar thing. Okay, what you can do is you can predict the label and you can compare with the exact label. Okay. So here the first problem that we are trying to do, we don't know anything about the data now. Just imagine that we don't know this analyst data. We just know, okay, let's try with the 20, basically 20, because it will take a lot of computation. So that's why I'm keeping it 20, and we will see what is the best number of clusters that you divide the data into, so that you can. Okay,
20 is the number of clusters or what?
20 is the number of clusters. 1 to 20. You want to try for 1 to 20. So this is what is happening. This is creating an empty model. This is training the model. This is finding the cost of the model. Finding the cost of the model. Right. This is training. Okay, so if we run it, APP see, it is number of cluster and it is the cost.
I want the range you have mentioned here, the 1 to 20. But is processing the same data set. We are not giving new data set, right?
Right. We are just trying to create 20 clusters, 20 possible clusters. I mean, it's not 20, it's not total number of clusters. First time you're using one cluster and seeing the cost, 2 cluster and seeing the cost, 3 cluster and seeing the cost, right?
The same.
Right, and what do you expect? If you increase the number of clusters, will the cost increase or decrease? Decreasing, right? So always, I mean, it will always converge. Okay, so first let me plot a graph and then we'll understand what is happening. That's right. L1 cost it is calculating actually. Okay, so this is the cost stuff. Okay, because for us actually it doesn't matter what is the cost. We want relative cost. Okay, so L1 calculation is a little lightweight, so that's what they did. Okay, so you can see this is, so now what do you want to do? I want to actually plot this graph. Okay, and basically cost is the function, right? It contains all the information, right? First, what I want to do, I want to multiply -1 to all of them, so that it is in positive. Absolute value integrated. Number is here. It doesn't take list. Okay, so this is your this is cost, yeah. So okay, now what you have to do, you have to find the best number cluster to divide the data. Okay, so what you have to do, you have to plot the graph. ELT dot plot. Okay, X and Y data, right? Range 1 to 20, basically. Then cost. Just see one thing in this graph. So you can see by increasing cost, by increasing number of clusters, the cost is also reducing, right? Which point, till what point the cost reduction is steep? Steep means, see, understand this line. Whenever you are trying to find this, what is the problem we are trying to solve? We have to find optimum number of clusters, right? And to do so, we have to find, see, anyway, if you make more cluster out of your data, you will get lesser and lesser power. But that is not what you intend to achieve. We want optimum number of clusters. Okay. So here you can check that d by dx of this thing, right? Yeah, so by seeing the graph itself, we should be able to tell what is the optimum number of clusters. Exactly. And you know why this is 10? Because actually there are only 10 type of clusters which is possible here, right? See, you can see the steepness here. After this, it is very slant. Like around this point is, and of course this cannot be, it should be a whole number. So you take figuratively to the 10. 9 or 10 or something, right? And so it really tells you that there are 10 good number of clusters, and that is what our data is. MNIST data, right? MNIST data means all digit characters are there, 0 to 9. Understood how we do it?
From 10 also it's
and 10 also it will always be slope, but this is known as elbow. You'll see a jerky thing here. Okay, this is how you find out optimum number of clusters. So an assignment.
That means that actually whatever the clusters we added, nodes added, is unused here?
No. Which nodes?
The whatever after 10.
No. After what we are doing here is we are finding cost for all the clusters till 10. I mean, one cluster, two clusters setup, 3 clusters setup till 19 cluster setup, and you are finding cost for each of them, right? And we realize that by increasing the number of clusters till 10, we are seeing an exponential decrease in the cost. But after that, there is no fundamental increase. I mean, if it has reached here, to reach double the stuff, it is actually doing very less slope.
Okay.
So, right. So you're already you have achieved the optimum number of clusters. Clear?
Yes.
Okay. Now, of course, 10 is your optimum number of clusters.
In the range of 1 to 20, it takes the 1 as a model, right? Okay. So it means with the data set, it optimizes every time the cluster, the center point and realign and recenter point. Such a way it's do for everyone.
Okay, I couldn't follow. Like that for every cluster. Coming in, then repeat it. I lost it. Okay, Bhuvan, can you repeat it?
No. For 1 to 20, we have given the models, right? In the previous picture visualization kMeans which you showed it, the data and the clusters. So we realignment every time and do clustering and again realignment, which is the closest, then again realignment, like that we'll do. So in that way, for each 1 to 20, if 111, it will take it do it, and again go to second, like that it will do.
No. First time it will see the code here. So first time it will try it out with one cluster, right? The entire thing. It will find the cost. It will do for fitting everything. It will do score. It will calculate and all that. Then cluster number 2. Then cluster number 3. That is how it is going. Okay, one cluster.
Yeah.
Okay. Now.
So it's a fixed function that does that and all, right? For each cluster you will do this.
For each cluster you will do the fit, right? You choose. It is like, how do you configure number of cluster? You configure it like this, right? Like this K, right? And like I'll do like this is like finding number of clusters. Now you know that. So kMeans model is equal to so we now know that clusters is equal to 10. This is our empty. This is training the model. Right. So after training the model, what is that you will do? You will predict which cluster is what.
Is random state always equal to 0? Random state.
No, you can set the other thing. It is just randomizing your data that is just taking for training the model. If you don't give, it will choose different data every time. Predicted clusters. Okay. kMeans model dot predict. Okay. Digits dot data. Okay. Okay. So you have this predicted. So what is this output? Remember, the output will be cluster number. Right? This is not value. This is cluster number, because it has nothing to do with value, isn't it? Clear, right? So you can see the first data, it is classified into cluster number 5. So you want to see what is, so understood, right? So when this is cluster number for data 0, there is not value 5. Remember this. Huh?
Out of 20 cluster is a 50 cluster.
No, you have creating a cluster with only 10. Creating a kMeans with only 10 clusters. Okay, this belongs to 5th cluster, and remember, 5th cluster does not mean value 5.
We can see that, right?
So we don't, as of now we do. I'm not using labels. I don't know what it looks like. Okay, let's see how is it. We don't know the labels part, huh? So now 5 is there, right? So we want to see all the data which is categorized into cluster number 5, right? So how will you do that? np dot where predicted cluster. Okay, this will be index number of all the data which is categorized into cluster number 5. Okay, now what you want to do is okay, this is cluster number 5. Now what you want to do is where cluster number 5. Now you want to see all the data inside it.
Okay. Start from 0, index 0, 1, 2, 3, 4, 5, 6, 7,
0. Okay, these are cluster number. Cluster number 5. We don't know what is contained inside it. For to understand what is the content, either we know some label of some data and then we map, or we see all the data, then we create a picture out of it. Okay.
Digits dot data of 0 is classified as cluster 5.
Huh?
Digits dot data of 0 is classified as
Cluster 5. Exactly. See, 0 is classified as cluster 5. See this here. 10 is classified as cluster 5. 20 is classified as cluster 5.
Then these are is like data of 0 part.
Possibly. Not all. Sometimes you may write 6 as 0. Sometimes you might write 6 like this, right? So it might be able to, it might not. There will be, of course, failure cases and successful cases. But yes, more or less all this data should be of type 0 only, something which looks like 0. Let's see some of the data, okay? Yeah, I am sure. Which one do you want to say? 30? One 768. See, this is a very ugly 0, isn't it? But it is able to identify it.
1760 when you write how it
See here, these all are indexes of the data which is getting classified. See, this is the condition that I wrote. So this is what you're doing here is get index of all the data getting classified to
So the actual level is only from 0 to 9 only. Actual target.
Okay. Indexes. Yeah. So now you want to see how much accurately. Now this part is clear, right? It is getting. So now you want to check how much accurately is it identifying this 0. What we'll do, we have label for all of them, isn't it? We will see, what is the label for all of them index. Understood, right? So
whatever the index number for cluster file, it is kind of unique.
Right. Whatever number you will, it's similar. That means all similar looking thing, it is grouped into this cluster 5. Okay. So actuals 5. We'll see this. So we have index, right? This is a cluster 5 user index number, right? So what will you do is digits dot data, right? Then actuals 5. Oh, sorry, digits dot target. See, this is all 6. See, 6 it is identifying, and 2 it is identifying as 0 somewhere. Apart from them, everything is 0. Right. So these are misclassification. Let's see what this. How do we count the number? Can you reach this point?
Avanti, can you please, after that graph, the cost is decreasing. After that, I couldn't able to follow completely. Somewhere something is missing. So could you please just a brief on that after the cost you have drawn?
So after costing, it is I'm using one of, we realized 10 is the optimum number of it. Okay.
So
realized that 10 is optimum number of clusters.
So after that 10th cluster, all the values are same. So that why we are took it as a 10, right?
No. Here using this elbow method, right? You are finding that 10 is the optimum number of clusters. Okay. Like after this point, what happened? You got disconnected or what?
No, actually, what happened? I don't know. I couldn't able to follow after this thing. That's why I just
Okay.
asked you to just brief on it.
Yeah, we realize that 10 is the optimum number of clusters. Okay, because after this point we don't see the dip as we see it here. Okay, since there was not exponential dip in the cost. Okay. Then we trained the model, then we did the prediction here. Okay, and after that prediction, we can the prediction. What will this prediction yield? Prediction will yield the cluster number. The prediction is cluster number, not the label. Okay, the cluster number. So this is the cluster number. That means first data gets classified into cluster 5, 7. Second data gets classified into cluster 7. This is cluster 7, and okay. So here, okay, cluster 5. I mean, we want to see all the data that is getting classified into cluster 5. Just an example. Okay, then we saw this, that all this data, this is NP where predicted value is equal to 5. That means it is finding you all the clusters, all the data for which it is getting classified into cluster number 5. This part is clear?
Okay.
Okay.
Yes.
Then we are seeing the contents of it. This is all the data which is getting classified into cluster number 5. Okay. Then of course we are seeing data. This is how 1, 0 looks like. We can choose anything of them. Okay, now we want to see how good is our clustering now without knowing the level. Okay, you can see here it actually this is target. This is the index number of the data, right? You can see here a lot of them are 0. Only 2 misclassification is there, right? Okay, so this is what we see here. That means what is the idea about this cluster? This cluster will contain all zeros. So now you get any new data, if it gets classified into this cluster, you can say with some confidence that this is 0, isn't it?
So this is a cluster 5, right? And what it is 6 and 2? These are all mixed classified one.
Yeah, these are misclassification. That means a data which is 6 actually got classified into, because it might have looked like this. Okay.
So it should be 0. The cluster 5 is
right. This is actually C6 which somebody has written, but it is getting classified as 0 cluster.
Okay.
Next one, cluster 7 is there, right? That one, we need to take only one. Yes, should we take one cluster? If you go there, number 5 is cluster 5, cluster 7.
These are other clusters. We can do the same thing for 10 clusters.
Okay.
Got it, right? So 3 and 8 is very ambiguous in nature actually. We want to do 3 and 8. Related this. Understood, right? This thing?
Actually, the cluster 5 contains 0. Then how did we got it where it contains 0?
I'm printing it like digits.target. Target is the actual target information, right? This is a verification stage. Okay, so we are just seeing, whatever is the content. Since we know a few of them, okay, or in this case we know all of them. We are seeing, okay, all of them is 0 except for these 2. That means anything which gets classified into, which gets into this cluster means they are 0. Right. Similarly, if you want to do it for 3, so this is cluster 3, isn't it? Now I want index number of all cluster 3. Already got. Okay. Now I want to see actual contents of this. What is the label information in this cluster 3, right? So what will I do? Okay. Dot target. Digits dot target. Okay. And pass here. No. The cluster 3 is your all index. Oh, sorry. So you can see here, this is a lot of misclassification here, right? This is cluster 3. That means you can see 8, 9, 5, all these things are here. But
what is the actual
Cluster 3, what is the actual?
So what would be the actual? I mean, how will you say? You'll say whichever is the majority, isn't it?
We can see the picture, right? What is the
First we can check how many of this, then only you can see.
So very, huh?
First of all, we have to see the count of 8, 9, and 5.
Then only there is a utility present, okay, which will give you the majority of it. Okay, that is cluster.
What is the picture that is predicted?
Huh?
What is it that predicted?
Wrong.
No, what is the predicted? What is the value that is predicted? Cluster 3 doesn't mean it's 3 number 3.
So we don't know that.
So that we can see that.
Yeah, we can see that, but you know, as it looks like it is a lot of misclassification.
No, I'm asking about the picture.
Oh, picture. Let me show. So we can see one of them, and you know, even blt dot im show. Five. It's really confusing for us also, because less pixels are there, right? I mean, had we used that memories data with larger pixel, it would have been much more clear. Right? It's very difficult to identify this. Right? This is how the actual image is.
How do you identify it?
This is standard data. 8 cross 8 pixel. Oh, that is because it is the data is in 64. Okay. I mean, it's not. I know they have told us that, you know. I mean, if you see how this data set is, okay, they tell you that it's 8 cross 8 data. Like for images also, right? They will tell you this information. What is the image pixel size? Okay, but pixel size, if in case you don't know, you can right click on the image and you can see the size. I mean, you can get the pixel size from the image itself. Property. Understood, right? So this is how this looks like, and this is it is identifying this is 5. Okay, but you really want to know what is majority here. For that, you have this scipy.stats.import mode. After this, not this. Okay.
So we don't know what it is actually.
So what will you do? You'll use this guy mode. So 9 is here, and 9 is repeating for 139. So 9 is in majority. So you can say this cluster belongs to 9 at least.
So how to fix this misclassification? We can run more algorithms.
No. The way to handle this, I mean, that is where your deep learning and all those things comes into picture. Okay, but misclassification is basically in this case because you have very small data size, very not clear. So if you have larger images, then it might be better. Fine. Now you want to see the centroids, right? What will be the centroid of 5th cluster? If you want to know without this also, right? If you want to know what is the contents of cluster number 5, majority. So if the cluster number 5 contains, in this case, what does it contain? 0. So if I print the centroid of that cluster, what should it look like? 0. Exactly. Right, because that cluster contains all the zeros, so centroid of the cluster will be 0. So,
but it is mode of 0. What is it?
Huh? Oh, the mode on O. I have saved this guy. Digits data, right? And I'm using this guy. It is finding 9 is the data which is repeating maximum number of times, and the time is 139. Okay, kMeans model. Okay, got cluster center. Cluster centers. If you do, it will give you details of each centroid. I want to plot each of them. Okay, so I'll do basically like this. Plot 10 centroids for for centroid in this guy. So here every time you will get a plt.im show dot centroid reshape 8,8. Last one it will show, right? plt dot see this is each centroid.
This looks like 7, 3, 5, 6, 7, 1, 2.
Ace. And done right now.
Machines.
3,
5,
9,
9.
7.
Is it?
Not 7, it's not.
0,
0,
1,
1,
3, I guess.
1, 0.
1, 2, 6.
Huh? No, I don't know. Of course, who will remember? This is 1. This is seems like 3 actually. See, not only line, you have to consider the color also. I mean, the weightage of color and all that. I know yellow, green, blue. Squeeze your eyes and see that you'll see. Okay, I mean, these are the centroids. This tells you what is it. Huh?
Actually, which color is centroid one?
Actually, let me show a little cleaner. No, all these are centroid actually. Okay, let me show. Let me see if I can plot it in a better way. Now it is better. 3, 4, 5, 9, 0, 1.
1. It looks like 7 or somewhere.
This is 6.
Yes.
This is 2.
2.
This is I think this is that confusing one, 8, 9, that one, right?
Actually, this is misclassified one. It looks like 5, 4 in between everyone.
Yeah. So there is something that you misclassification. That is the one that we saw perhaps. That has a lot of misclassification.
So, can we tune this thing, or should we again we have to learn the model?
No. You can. You cannot tune this because this is the optimum thing. You know that 10 clusters for sure is optimum. This is like handwriting data, so this will happen. Okay, this is not cleaner data that you can process it. So this will happen. Now, of course, if you use better learning algorithm like deep learning and all that, you might get a little more better results.
There's some boosting here, like very.
Unsupervised don't have that. Okay. So this is one of the kMeans technique that we are seeing.
So is there any other unsupervised algorithm other than kMeans?
There are a few. Okay, there are a few dimension reduction that we do, and there are a few. Okay. PCAs. Okay, and a few things will discuss.
PCAs are for feature extraction, right?
No. Yeah, that is unsupervised. Okay, that is one use case of PCA, but that is much more.
So if you change the 10 to something else, this it's a result that seems not clear.
It is. Okay, not totally, but yeah, how far you go from 10. In that case, what will happen? 2 will be in multiple clusters. Right. Now we'll do something about image. Is it clear now? Of course, I mean, if you have to find accuracy, what will you do? You will find for each of the image what is the. I mean, we can now create a mapping, right? Okay, what will we do is we'll do like this. If you want to find what number means what cluster, what cluster means what number, we can do the mapping, right? For k in range 10 0 to 9 to go, right? So we want to do every mapping. Okay, so what will you do here? What is the values? It finds what will first do, it will find all the 1, all the 0, print k mod cluster. Why is it like this? Oh, that was mod or mode?
More.
Why is it like this? Alright. Cluster, sorry. Oh, cluster will give you data from 1, 2, 3 indexes, right? Yeah, that is what I know. So what you have to find out is the target information. Yeah.
Building range 10 means it will take from 0 to 9.
Right.
But k is always 10 we selected only, right?
Huh?
K is 10 only, right? For 10, what are different values that we is finding it? K is 10 is fixed, right? Because we have 0 to 20 to check.
Right.
So 10 is fixed. So why are you doing k in 0 range?
No. This key actually, this is not. This is centroid number, cluster number. Cluster number. Cluster number. So this will be the cluster information, and actuals digits dot data. Oops, sorry. Digits dot data cluster. This is your actuals, right? On finding the actuals, now we will do this mod. Print cluster number, comma mod. Is
data fabric, so we get easy.
Oh, not data. It will be target. Yeah. So now you can see 0 is 4, 1 is 3. Okay, then 2 is 5. So you can see here the classification. Right, this thing, whatever we have done it above, I just have looped it across for all of them.
It
will find indexes, where this criteria is matching.
This means there's cluster 0 as 4 something.
Cluster 0 is actually a lot of contents are there. It is 4.
This array of 1 means model 6 years it has model is called array 1. Sixth one. Sixth one. Sixth cluster is six cluster. Only one.
1. That is a confusion cluster, right? Okay. So it is identifying as a 1 and it has 50 times.
One number has 55 times.
1 is the maximum order. Understood, right? How to infer this and seeing this is unsupervised. So you're getting some sense of the data, getting some understanding.
So 5 is the one which we worked with. We used cluster 5 is shown as 0.
So cluster, this is cluster, it's not this one.
5.
Cluster, this is cluster number 5.
Which we worked,
right.
Actually shown here.
Clear, right?
Yeah, 0, 177, and 2 are there, which is 1, 6 and 2. Total 179.
Right.
So what are this count array 163, 154? What it is?
This is your the value that is maximum times repeated there. That means this cluster number 0 has a lot of 4. So anything which gets mapped to cluster number 0, any unknown data, okay, you know that it is 4.
Can you play? So for example, cluster 5, array 0, right? 1170 are there, right? So can we just say in cluster array 0, total how many numbers are there, out of which this is maximum?
Yeah, you can do that every time you are printing cluster, right? You do size of it. Okay, cluster, total cluster size of it. If you do, you'll get it. Fine, right?
This centroid is actually
This cluster's point from which the cost function you calculate, right? Centroid. The center in the diagram. After everything is done, this is the centroid. These are centroids.
That's clusters of red. Then we can say clusters of red. Centroids are clusters or what?
It's a cluster.
Centroid are clusters.
Cluster
is this entire thing. This is the centroid.
Centroid connects clusters.
Centroid is the center point of clusters. 1, 2, 3, 4, 5.
That's what centroids are.
Centroid and cluster. You're asking that number of clusters and number of centroids are same or not? Yeah. Centroids are nothing but center point of the cluster, from which the cost is least.
Centroids will be the predictor value also, right?
Initially, it will be a centroid and it will connect all the points and form.
That is the predictor value. For example, if I'm predicting 9, so 9 will be the centroid of that particular cluster. Right. So when we had 9 points at 0 to 9, but here only 5 clusters are there.
This is I've devised it in 5 actually.
Oh, okay, well, that's it. So, like that, is it possible to see for hours also? Data?
Actually, the problem here is this is only 2-dimensional data. Our data has 64 dimensions.
Okay, please do stick with the increased it to 10, right? Still 500. Okay.
Then
But how will know how many clusters we use, 5 or 10 or 15?
Here what we learned, right? Elbow graph. That is not the elbow technique.
like this is
Let's teach them.
Right.
This shell put like this or?
From here to it,
Yeah.
from there to slash.
From this slash.
Yeah, then this is standard term. It's not a point. It's a standard term. Okay. So now we'll do an image compression with this technique, kMeans.
In kMeans only the K and the center is important for this one, right? That is the two.
That is the things.
So when is the calculation calculated? Is it necessary to do it?
No, it will do it all by itself.
What you have said is count array 177. The number of times the cluster is repeated. Is it right? The count equal to array 163, 154. What you have said is number of times the cluster is repeated. Is it so? Or?
No. This is how many times 5 is appearing over here.
Okay. So 163 times the 4 is appearing. 154 times 3 is appearing.
Right.
Okay. Thank you.
Okay, so here we'll see this color compression. Okay, and in this process, I will tell you how to load your image. I think last time I didn't show you how to load your image. Okay, there is a utility that is known as scikit image imread. Showed, no? I load my image and we'll try to do color. imread only, I guess. From skimage.io import img. So okay, let's load some actual image. Okay, I'll see if I have. Images right now. It's synced from my phone.
It should be inside.
No, I want to image. Okay, so what will I do is I'll No,
I don't like snakes.
you are still writing Python.
Image.
620 on. Let's see this image. We'll make colorful Python. You can't see code. Oh. Wait. I mean, don't worry. We'll make it good looking.
Image, I don't want Python image.
Okay, let's try something else. I wanted some real image.
So by the way, why did the name always say Python, Anaconda and all?
Endangered species actually. Endangered species.
Like in Android, they name their versions based on snacks, right?
This is fine, right? From primary school teacher. Primary-teacher.apg, right? Okay, it's gone. We are safe now. Okay. So see this how you do it. So this is the content of it. Understood, right? Okay, so you want to see the shape of it. Okay, and you really want to see the, do the reverse content and img. So you can see 295, 463. And if we want to show this data, IM read and IM show is just reverse of it. ELT.IM show. Fine, right? Okay, so what we'll do is we'll now do the reverse here. Okay, we'll do color convert. We want to convert this image into 3 colors. 3 colors. So and remember the idea. So you have a lot of pixels. Okay, a lot of pixels here. So how this image is represented? Each pixel is like 3 values. So the entire data is you to multiply 295 into 460, and that will be 1 pixel. And each pixel is represented with 3 values. So you have a lot of possibilities of colors. Like yellow here you see, right? All the yellows will be of same pixel values, right? So and this color and this color is pretty much same. Okay, so centered of these 2 colors will be same. So what will your data be? Your data will be entire set of pixels. And what you have to find? You have to find 3 centroids, 3 clusters. Okay, let's see.
But 3, which it has defined there, that will be the cluster sum, which has given the shape. The shape it has given 3, right?
That is not. 3 is RGB. Colors, yeah. I'll write it here.
Why you decided to have 3?
4. Yes, 4. Okay. Yeah. Now let's have piece here. 5. Oh, then I better use some other image because this does not have a lot of color.
No, this is only better. Otherwise,
Python looks better.
Okay. 3 for RGB.
Actually, 3 is confusing with RGB.
Chalo, take it. 4. Let's have please. Okay, 4. So what we'll do is we will try to have 4.
Check the Google image. I think it contains all the colors.
That's enough. He is finding you guys can do as an assignment. Okay, we will try to have 4 colors. Color image.
White is there, gray,
yellow.
Green, yellow.
There are a lot of colors. You can't see like there are different colors of green, there are different black, gray, a lot of colors. Anyway, there is a lot of colors. Okay, so we'll convert this into 3 colors. Okay, now first thing that you remember, whenever you have some image data, right, you have to divide it by 255. Okay, 255.0. Basic reason is whenever you're doing image algorithms on image, right, this is a scaling technique. Okay, you should convert data between 0 and 1 to get better results.
What is
Zero and one.
For image data, convert each pixel value between 0 and 1 for better accuracy. Understood?
0 minus 1.
0 and 1.
0 to 1.
Okay, so whatever data we have, IMG data, IMG data is equal to IMG.
Why 0 to 1? Is it because of some activation function?
No,
that's
not it.
ignored?
No. It is basically when, I mean, this is the scaling technique. Okay, this works good for images. Okay, this works good. 255 because your each value can pixel value, right? 255 basically the maximum value of each pixel can be 0 to 255. Okay, maximum pixel value, right? Dot 0. So now it will convert that into, see, all data is between 0 and 1. Fine, right?
Yeah, previously it was 255 to 33 to
Right. Because the algorithm works better here. That's the purpose. Okay. Now, what is the number of pixel? Okay. So now you want to reshape it. Data into, what is the dimension of data? 295, 460. 295 into 460. Okay, and this is the data is changed now. Okay, I mean just the vector dimension is changed so that it becomes two-dimensional stuff now, so that you can pass it in your training data set. Now, because your training data need two-dimensional information. Okay, image data dot fit. Oh, sorry. kMeans. Remember, just one image, one small image.
4 colors.
4 colors.
So we assume 4.
4 colors, yeah. Number of colors is equal to 4. Right. Then you have this.
What is LI for jobs is equal to what? LI for jobs is equal to what? This algorithm. Now could we see that LI from jobs is equal to what?
Oh, n jobs is equal to n job number of, actually, if it is multi-threaded application, how many threads it is generating internally and all that. So it is doing it as a one job only. Okay, number of threads. So now you have done this. Now you want to see what are the average colors, isn't it? What are the average colors? So, or what are the total number of centroids? 4, right? Okay, so you want to see what is each pixel getting mapped into. So it will be prediction. Predict compressed colors mapping. Okay, this is like each pixel is mapped into this kMeans model dot predict. Okay, IMG data. Okay, so if you do colors mapping, okay, you will see 0, 1, 2, 3. Between data will be between 0, 1, 2, 3. Right? Only few of them are seen here. Okay. Wait. So that means one color is dominating.
So 7,000 lost.
You can do the stand to find out what are the numbers. Count.
Color is dominant.
Unique you can check, right? Not unique. Unique values of
Yeah, I mean we can do that, of course. Just
No, something. For show colors, we can do.
predict. What is it? Image data. Oh, 3 of course will be higher, right? Yeah, mean we should do.
Mean or no?
0. So it is, those other things are here actually. Okay, just that we are not able to find. I think yellow or some color is very much. I mean, and again, see the number of pixels is way higher, right? See 295 into 460 into 3. So way. So let's see it. Okay, let's see all the colors. Okay, so what you can do is kMeans model dot cluster centers. This will show you 4 pixel colors, 4 definitely chosen center mean colors, right? Okay, this is 1, this is 2, this is 3, this is 4. 0, 1, 2, 3. This is all the data which is getting mapped to cluster 0 will get now this color. Okay. Yeah. So what we have to do now is.
What are the column indicates? Column indicates what?
Which one?
Column.
Column indicates this is RGB.
6 times of red there.
No. Yeah, I mean scaled at R. This is the value of R. This is the value of G. This is the value. This is one color. Which is mean color of, which is the centroid color for all the points which comes here. So I mean we can do the we can actually print this guy earlier that we did to find. Okay. Okay. Cluster NP predicted. So color mapping.
Cluster as the number.
No, this won't be useful. I mean, we'll have to compare, and we don't have anything to compare. But essentially, these are like 4 colors now. Let's see. Okay, now we'll use this 4 color to convert the actual data. Okay, let's see what I mean. This is 1, 2, 3, 4, right? And this is the, remember what is the process here. So now, what will happen if I do this? What will happen if I do this? This is 0, 1, 2, 3, right? Color mapping means what is the value of color mapping? It will be between 0, 1, 2, 3, right? If I do this, see for each pixel I'm getting new value, isn't it? Understood? What is this? This is like, I mean, this is like one of these 4 values and giving the index on 1, 2, 1, 2, 3, 1, 2, 3. So it is generating you. Okay. No, this is huge. This is image size. See?
Why we need this one?
We see what is the purpose. What is the purpose is rather than light yellow and dark yellow, it should have a find an average color, mean color, right? And which we did using cluster centers. Now you want to replace light yellow, dark yellow, deep yellow by this centroid of the cluster, right? That is what we are doing. Okay. Now this is the final color. Okay.
This image we can see graphically with colors.
Colors. That's what I'll show you. That's it. So color mapping, new image. Okay. I mean, once you see the color, you'll actually understand. So it crossed 3, right? You want it to be reshaped. So to the same stuff. 295 463. 295 460. This is your new image. You want to see the new image now? But remember, new image you have to multiply by 255. Even if you don't do it, will work. But three colors.
Yellow was there, right?
Yeah, it calculated the mean of yellow and found out this color.
But it should appear, right? Yellow we see clearly, but the yellow will not appear.
It calculated mean pixel values. We do one thing.
Max.
1, 2. No, the purpose here is just image compression. Just see one thing.
So this is the one which is
Understood, right? Let's see. No, the 255 I did, right? That actually darkened the stuff. I mean, of course, it would be 3 colors again, but it is darkening all of them. I mean, getting to the larger scale.
That will divide by 2.
That is a downscaling, and this guy works well with. Now the number is between 0 and 1, right? Okay, so this guy understands it, and you can see in just 3 colors we are representing the entire image. Of course, 3 colors only, right? And
black, white, yellow.
Black, white, yellow.
Only 3 colors.
Black, not white, cream, white, and yellow. See, I mean, it actually calculated. I mean, this image looks very similar to, I mean, compressed image, right? Now, what you can do, you can use like GPG, all those compression algorithms, but you can do all this same looking color. You can put, okay, all these locations have this color. All these locations have this color. So your image will be much more compressed.
One color.
Now,
so now how your image compression actually works is, okay, what you're doing here is you're finding mean of all these colors. Okay, now how do you do image compression after this? You can write all this pixel location this color. All this pixel location this color. So your image, see what is image? Image is nothing but array of numbers, right? If you can find out a technique by which you can use lesser space to store all those information, that is a compressed image.
So in what way it benefited?
It as of now it represented the same image in a compressed format.
No, what's the use then?
Generally,
why we use
image compression? When you click an image with DSLR, what is the size of it? 50, 60s MB image. Is that image usable?
Oh, okay.
So you apply JPG, your PNG algorithms are nothing but image compression techniques.
Okay, that big size we are converting.
And in such a way that it doesn't, impact our eyes, because our eyes are capable of identifying some 65,000 colors. Okay, so they want to retain that as well.
The thing is, when you compress, suppose this is raw data, right? PNG and all is raw data. JPG
no, PNG is not. No. It's PNG data, all compressed. Raw data is raw or some file format.
.raw to JPEG when I convert it. It's a compressed image, but still the color is not lost, right? When I decompress it again.
No, that is, see, there you are compressing to some 65,000. Here we are compressing to 3. Okay, so this is, I mean, the purpose of here is to just show that, this is how image compression actually works. If I work on 50 MB data, then, one image itself take whole day to process it. Okay, this is a very small file that you see here. I'm compressing a compressed image.
Compressing.
Yeah. Understood
But
this?
method is same only, so
Method is
same only. Even at 50 MB or
basically you are finding for different colors of pixel. Remember this technique. What you are doing is you are finding what is a mean color, and you're replacing all those pixels by that mean color. That is what we are doing.
But when we're doing computer and now using Photoshop, we're stuck. We'll finish with something.
But because executes all these algorithms.
No, but see, even if it is 60 MB, it hardly takes 1 minute to compress it. But here it is, you're saying it's taking 1 day, 1 day. So is it a better algorithm they're using it?
No. So see, there are multiple things that happens. Okay, one is computer means you're saying mobile photos, sort of a thing.
Could be camera or
right. So even after in Digicam, you are doing this image compression in Digicam, no, right? You need you can copy it in some application. So you might use your system and all that for that, right?
No,
then camera will have something. Essentially, this is the thing that happens, but it might have some special hardware which is capable of doing this. Okay, I might not know that thing, but if I use 1024 image and 1024 image, right, it will take easily 10-20 minutes to execute. Okay, so I mean this is anyway compressed image.
Can we know what are the colors it called? Cluster. No. Text form or something. So which is called cluster.
You can find it out. All you have to do is what is the cluster number of this pixel, what is the cluster number of this pixel, and the way we did it above, right? We can group all the NP where you can do. You can find all the pixels that were clubbed into this color. That you can do.
kMeans can be used for text processing.
Like you have raw text coming in, you have to find. Actually, I'll tell you a good business case. Redbus used it. So they have review comments from different people, different about a bus. So they earlier were doing manual classification. This comment is for this class, this comment is for this. And also a lot of people they are usually not skilled workers who does this stuff. So now when this data came to their machine learning team, the data was completely useless actually. They realized a lot of workforce they have already hired who is doing this work is not so relevant for actually laid off that team. Okay, so here what happened is then they did whatever data they got right, text data, they used an unsupervised algorithm, kMeans, basically to find groups of the data. This is similar data, this is similar data, this is similar text data. Right, on preparing such groups of data, then you can see the data and then you can analyze more. This is like data cleaning activity that you are doing, data cleaning, data grouping activity that you did with kMeans. Right, a lot of review comments are, you don't know which category to put them. First, you at least need to bring similar comments in one bucket, right? So that some skilled workforce can go on top of it, see what is matching, what is not matching. That is reducing some workforce effort.
So those were reviews when you talked about data
earlier. Now, yeah, reviews.
So we can use that supervised, right? Because we had a good, bad, not good.
No. People may not write good, bad. Just review.
Right.
People may not give rating also. Just review. And not only good, bad review. They want, this is about bus timing. This is about bus cleanliness. This is about this thing. Right? People will have not that much of category in the data. I mean, people may not choose category or may be relevant, may not have category. Who will choose fill up a form to give a review? People will simply write text. Okay, based on the text message, you will identify this is the class. This is because of bus timing issue. This is because of conductor conducting issue. Understood, right? Canceling issue, right? Receipt, so money refund issue and all that. Understood kMeans. So I mean, if it is text data, what you have to do, you have to just first run tf idf, convert those text into vector. Once that is done, apply this. I have some blog data, but I think it was a little too much. Let's see. Oh, 112 MB data. Let's see if I can load it. Blog feedback. Huge amount of data, right? There will be a train data. Log train data. I think it's done now. So this file I'll load. Blog data underscore train. What the hell? Why is file not found? Oh, that is because /b is there, right? Escape sequence.
Why are we using the dark many times?
If the escape sequences has start yeah, this /b, but again that is not the problem. I think file is it not the file name.
What?
Data. Oh, yeah, wrong file name. Block feedback. I'm not written it completely. Yeah. Now, numbers. So this is a number parameter. I forgot. Add review comments data. Reviews.
ಹಲೋ ಚಂದ ಏನಿಂದ KPIT ಹೊಸಲಿಂದ ನಂಗೆ ಕಾಲ್ ಬಂದಿತ್ತಲೆ ಅಂಜಲಿ ಅಂತಂದು
Reviews.cs. Yeah, I've copied another file. This is also a huge file, actually. 286 MB.
281 columns.
Restaurant review comment. First, let's load this. Then load this. So it has a review comment. What we'll try to do from that comment, right? We'll try to find groups of it. What is the optimal number of groups? Then you can see that. So you can see, of course, a lot of information is here. And the important part is the review comment here, if you can see it. Text part, right? Blog data text. And
here we have targets.
Summary is this. Okay. This is so what we'll try to do is we just from this review comment, right, we'll try to find what is the optimum number of clusters, or but remember this is a huge file. Okay, so if you do info of it, I think 5 lakh reviews are there. Will take us 1,000 or 2,000. 5,68,000 data. That's okay. I mean, like at the end it might take some time. We'll leave it, but at least we'll have the result. Summary has not value. Text has any full data. All we need is this text. We really need to do some analysis. We just forget about other thing. We just got text here. Okay, blog data, blog text, blog data. Right. So this is all the information block text.
So everything will be unique, right? We cannot do unique stuff.
Everything will be.
So generally we used to go with unique and we need to change this. Here we cannot.
No, yeah, here you cannot actually. So you have text data. So now you have to do some tricks here. Okay, first is what you have to do. You have to find um, find important words, not just all the words, important. So yeah, one of them is TF-IDF, right? So you have to use this technique and do it. Okay, let's start. Okay, so first thing is
Avantik, are you writing something over there?
no, not yet. I'm just trying to find something.
Actually, I can see up to text you have printed.
Right. No, not much. So just first I'll start with count vectorizer. Okay. So now you do count vect. You go to count vectorizer. If I do this, count vect dot fit transform block text block text dot text, right?
What do you use the label encoder here?
Label, actually here you have number of words are infinite here. Huge. So label encoder is good when you, in a particular column you have fixed option of words.
Only words.
Fixed option of words. Here you have huge. So first if we'll use count vectorizer, it will give you some information, right? I mean, how many times a particular word is appearing, and you will filter out some other words which is appearing only once or so. So that, I mean, those words do not matter. Okay, so like this sort of technical label encoder you'll use only when we have fixed male, female, location, right? Fixed. Here it is not fixed. When you use count vectorizer, you have TF-IDF vectorizer. How many departments? Then you'll use label.
So we do count vectorizer, take the maximum words and then do the label encoder.
Not label encoder. You'll do either you do with count this guy, or you can use TF-IDF transformer actually. Okay, I mean, you can try with both the approaches. I first did with this. So here, remember, I actually might be a little more consistent. Okay, but you know what will I do, right? Eventually, after this activity, the text processing, I'll have lakhs of columns actually. Right, each word will be one column, and right, and each column will have some counter in it. Right. Similarly, for TF-IDF vectorizer, each word will be there and some weightage will be there. So essentially, what is the output of all such pre-processing? Some columns of numbers. All I have to do is apply kMeans on top of it. Okay, apply kMeans with different number of clusters. Cluster 1, cluster 2, cluster number of clusters 3, number of clusters 4, the way we did initially, and then it will figure out plot the graph. Oh, it did it. Right. Now if I do, see, it is 1,20,252 columns. Right. Okay, so this is a little bigger column for if I try to see it, probably I mean, I cannot afford to see the data, but let me try to do kMeans here. Okay, I'm not doing for all of them. Okay, because that will I just do for 10 classes. I typically want to do for 10 classes, but we can write the same code for all of them, find cost. Okay, just for or rather let me do it. Okay, but it won't, the execution will take a lot of time, huh? It will try for all this thing. Oh, this is a model creation part. Okay, K and kMeans score. What else? No, that's okay. Okay, so it will try for all the models, give the cost. Okay, then after that you'll figure out these are the possible classes. Okay, I mean possible. Then we'll do the same steps that you did. Okay, of course, this is one technique. You can use other techniques and do the changes here.
Last week's video is uploaded on YouTube. I got not nice.
Then we'll upload now. Record. I'll upload it now then.
I think 3 also.
No, just did the conversion.
Only 3 other is one question and
No, other will also be there, but not in this 3.
because Cycling 1, 2, then Titanic project. After Titanic, there was one more video. Then last week, I guess.
Is it? Maybe the Titanic project name is like that, but it might have a lot of other things. Last week we had only one cluster.
Last week, I don't know. We have other videos. Right?
The dates, recording will be dates wise, it will be there.
It will be there, right?
I'll upload something else. I'll check it today. Okay, let it run, it will take some time. Okay, let me upload it, this code also. No, now we can see it, but this is not yet ready.
No, actually, I want to see the
Diagram.
diagram on show one diagram. Where is it?
There only. I will just show it and upload it. GitHub.
Diagram with data cleaning download. Yes.
Okay, go here.
In this,
it is in this section, introduction to machine learning.
I see code issues.
Second.
Data.
Yeah.
The data I see house rental data pattern. Movies too.
No, data. Data I will upload. I mean, it's still
No
in
data. I want to see data. Morning you should.
diagram. Diagram is here only. Click on this. Okay, here is the diagram.
Introduction to machine learning.
Okay, so go through this kMeans. Tomorrow we'll learn one more unsupervised classification. Unsupervised. No, I will finish classification. This guy unsupervised. Okay.
So random forest is supervised.
Yeah. Okay. Then we'll go for, you can come back to supervision, supervised.
So this class over. This one question. We have the Sandro NG this course, right? So if you are looking for a job outside for ML or something, so we have to. Is it good? Like if we have that certificate, or it's not required?
Well, the thing is, no. I mean, getting that certificate is actually very easy.
Is it?
Just listen to the videos. I mean, it tests your coding skills. Yeah, knowledge. I mean, it's pretty much
it's not required.
Yeah, no. I mean, it's not credible information. The credible information is the project that you did, the code that you write. Right. But I mean, of course, I mean that content is very good. I mean, do it for not for just certificate, more for learning purpose.
But a lot of he teaches a lot of math in that, which we actually don't use it.
You don't use it definitely. I mean, see, having said that,